Hi, welcome back to Tutor Think. In today's video, I'll be taking you through methods of Laplace transform. We have a derivative function here. We will convert it into Laplace transform by solving through partial fraction, and then we will use inverse Laplace transform to find the final solution. So before you can start this work with me, I would recommend you to watch Intro to Laplace Transform Part 2, Transform of Derivative Using Notation. That is the subtopic. You need to look at that video, Transform of Derivatives Using Notation, because I'm going to apply principles here, how to convert a differential equation into Laplace transform. This is very important. If you don't look at this, you will not be able to get the concept I have here. It is a very short video. You can look at it. Locate this video in the playlist Laplace Transformation Engineering Maths 3. You'll find it there on this same channel, Tutor Think. Please subscribe to this work. And let's box on to what we have today. So this question says that find the solution x of t using the method of Laplace transform of the initial value problem below. And we have the square x dt square minus 3 dx dt plus 2x equal to 4e3t. And e here is an exponential function. He gave us initial conditions that t equal to 0, making x equal to 5 and dx dt equal to 7. So the first step is to convert each term into its Laplace transform. Okay, so from Laplace transform, what is the square x dt square? What is the x dt? What is the Laplace transform of the function x? And what is the Laplace transform of e3t? So we need to deduce that down before we start the calculation. So I'll start with the square x dt square. Alright, so but before I start, if you have watched that video, let's assume that the function f of t, they didn't give it to us here, but let's assume that the function that we have here, f of t, is equal to what? X. So the first derivative of f of t is f bar of t. This is equal to x naught. And then its second derivative, f bar of t, or f11 of t, should be what? X dot dot. Okay, so I'll use this principle to convert this one. Alright, so this is f of t. F of t, when we differentiate f of t the first time, we can write it this way, or dx dt. Okay, and this will give us the square x over what? Dt square. So do you get the concept now? So I'll apply that here. The derivative d square x over dt square can also be written as x dot dot, and I'll be using x dot dot here to convert into what? Laplace transform. So when we convert the second derivative into Laplace transform, the result will give you s square times x bar. Remember that the Laplace transform of the variable x is x bar, okay, from transform of derivatives, x bar. All right, so when we continue, minus s x naught minus x1. So converting a second derivative using notations will give you s square x bar minus s x naught minus x1. Then let's do the same thing for the first derivative. We have dx over dt. When we convert this using the variable x, we have x naught. Okay, so when we convert this into Laplace transform, this is giving us s times x bar minus x naught. If you don't watch that video, please, you'll find yourself in trouble. All right, so let's move on to this side. So what is the Laplace transform of the variable x? It is the same as x bar. 2 is a constant, so we can repeat it. So here we have 2x. When we convert to Laplace transform, the result is giving us 2 times x bar. Okay. Then we move on to the exponential function e3t. This is a constant, so I can use it to multiply. What is the Laplace transform of e to the power of 3t? Alright, so in the same playlist, you can locate the video Laplace transform of e to the power at. This result is going to give you 1 over s minus a. So the Laplace transform of e to the power negative at this result is going to give you 1 over s plus a. So when this side is negative, this is positive. When this is positive, this side is negative. Remember, a is a random value, okay? And look at this very carefully. We have 3, so a equal to what? 3. So the Laplace transform of e to the power 3t will give you the result 1 over s minus 3, okay? Now we take the Laplace transform of 4e 3t, and what are we getting? It is the same as 4 times 1 over s minus 3, okay? So now you can use this to multiply, and this result is giving you 4 over s minus 3. Now we have been able to deduce every function, each term, into its Laplace transform. The next step is carry all this result and substitute it into the original equation, which is what we have here. So we replace the square x dt square with this one, and we replace the x dt with this one. We replace 4e raised to the power 3t with what? This result. So let's substitute that. So let me name this one equation 1. Alright, so that I can be calling equation 1 to do the substitution. Okay, so this is equation 1. Let's do this substitution. So wherever we see this, we substitute that. So let me put them in brackets. I have here s square x bar minus x naught minus x1. We can close this bracket. Then we have minus 3 multiplying the x dt. The x dt is this result. So we have s x bar minus x naught or x0, whatever way you want to call it, plus, then we have 2x. We replace it with what? 2x bar. So plus 2x bar equal to this side. So we replace it with what? Its Laplace transform, which is what? 4 out of s minus 3. Now what is the next step? We just need to use this negative 3 to expand this bracket, and we have s square times x bar minus s x naught or x0 minus x subscript 1. Then this time this we have minus 3s x bar. This time this we have plus 3x naught plus 2x bar equal to 4 over s minus 3. Alright, so let me rewrite this equation, then we substitute the initial conditions. So when t equal to 0, x here becomes x naught. So we have x naught equal to what? 5. Then the x dt here is the same as what? X1. Remember, we are converting the x dt in terms of x. Then we change it to Laplace transform. So x1 equal to 7. If this side was second derivative, then this side becomes x2. Okay, so put that in mind because I explained it in the video I said you should watch. Alright, so now we put in this initial condition. Wherever we see x naught, we substitute what? 5. Wherever we see x1, we substitute 7. Okay, so I was supposed to substitute that before we expand it, but it's nothing. Let's continue. So here we have s square times x bar minus s. What value do we have here? X naught is 5, so we put our 5 in this bracket, minus, then we put our 7, minus, we have 3 s x bar, then plus 3 into what? 5, because we have 5 here, plus 2 x bar equal to 4 over s minus 3. So we are having s square x bar minus 5s, this is 5s, minus 7 minus 3s x bar, plus this time this we have 15 plus 2x bar equal to 4 over s minus 3. Now Look at this very carefully. We have x bar here, we have x bar here, we have x bar here. We can group them in one place, let's say the left hand side. Alright, so now let's group. We have s square x bar, I can pick this one, minus 3s x bar, then plus 2x bar. This is equal to 4 over s minus 3. Then I can carry this one to that side, plus 5s. So when we add 15 plus 7, the result is what? 8. When I use it to cross the equal sign to this side, I have negative 8. Okay, so this is what we have. Now we can find the LCM on the right hand side, okay, to reduce it into one fraction. Then we can use it to solve with the left hand side. So let's assume this is over 1, this is over 1. To make it very simple for you, let me take LCM here. LCM is s minus 3 times 1 times 1, the same s minus. This into this, the result is what? 1. This will cancel this, we are left with 1. So 1 times the 4, we have 4, plus 1 into s minus 3, the result is s minus 3 times 5s. So we have 5s into s minus 3. Then we have minus 8. This into this is the same as s minus 3. Okay, so now from here, we can expand this side. This is the same as s square x bar minus 3s x bar plus 2x bar. So when we expand this, this result is giving us 4. This time this we have plus 5s square minus 15s. This time this we are having minus 8s plus 24. So this is equal to s square x bar minus 3s x bar plus 2x bar. Okay, now we can group this side, but before I group this side, let me factorize x bar here. We have x bar, x bar, x bar. Okay, so I can factorize x bar outside, and I have s square minus 3s plus 2. This is going to give us 5s square. Then when I add this and this, the result is minus 23s. Then 24 plus 4, we have plus 28. All right, okay, so I left this. We're supposed to divide this by s minus 3 and this side by s minus 3. All right, so now we can make x bar the subject because we are looking for x bar. So when I make x bar the subject, I'll divide through by what? S squared minus 3s plus what? 2x. So when I divide, I don't want to cancel here. So when I divide, this is giving me 5s squared minus 23s plus 28. We already have s minus 3 here, so we divide this result by s minus 3 in one bracket, and then we divide by what? S squared minus 3s plus 2. All right, so this is it. So now x bar is equal to what? This result. Remember that when I divide this side by s squared minus 3s plus 2, I'll cancel it out, and I'll be left with s bar. When I divide, this is what I'm getting. Now, we need to solve this function. This is where we switch to partial fraction. And before we can do that, we need to break this down using our calculator. I don't need to factorize this. I'll just use the calculator to break this down. Right, so let's punch this on the calculator. So this is my calculator. If you have this type of calculator, you just press mode, and then we have equation as number 5. So you press equation, which is number 5. You select option number 3. So I press on 3. Then once I press on it, this is the equation. This is a quadratic equation for me. So now I can input the coefficients of s squared, which is 1. So you press 1. So this is my 1. I'll press on 1. The result. Then you press equal to. Then the coefficients of the s term is 3. So you press negative 3. So I'm punching negative 3. As you can see, this is negative 3. You press equal to again. then you punch the constant. The constant is number 2. So I'm pressing 2, and as you can see on the screen, this is my 2. So I press equal to. Once you do, x1 is equal to 2. So therefore, we have x equal to 2. And then you press equal to the second time, x2 equal to 1. So x equal to 1. So these are the roots of the equation. Very simple. So since we have the root to be x is 2, x is 1, you use this to cross this side. We have x minus 2. Then we use this to cross this side. We have x minus 1. So now these are our roots. X minus 2 times x minus 1 will generate the equation that we have here. Okay, when we multiply it, we generate. So we can replace s squared minus 3s plus 2 with x minus 2 times x minus 1. Okay, so now we have x bar is now equal to 5s squared minus 23s plus 28 divided by s minus 3. Then the first root we got was s minus 2 and then s minus 1. Okay, so now these are our roots. So now that we have been able to deduce this into this form, we can now switch to partial fractions. Now, if you are not really familiar with partial fraction, I'll give you a brief background. S minus 3 is a linear factor, S minus 2 is a linear factor, S minus 1 is a linear factor. Okay, so partial fraction says that if we have a linear factor, let's say S minus A, let me use A to represent these variables. Then into partial fraction, this becomes A over S minus what? A, where this capital A is a constant that needs to be determined. Okay, so if I have S minus A, then another S minus A, then into partial fraction, this becomes A over S minus A plus B over S minus what? A. Now we have 3 linear factors here, so we use the constant A, B, and what? C. Okay, very simple. So now when we resolve this into partial fraction, what will be our result? Let's do that on a fresh sheet, okay, because I'm not sure we can write it here. Okay, so into partial fraction, approximately we are having A over the first linear factor. So let's pick the first constant, A over S minus 3. Then plus we have B over S minus 2. Then plus C over S minus 1. Okay. Now, once we change this into partial fraction, we focus on the right hand side of the equation. Okay. And let's take LCM here. So taking LCM on the right hand side, what will be our LCM? This time, this. Okay. So we have S minus 3. We have S minus 2. S minus 1. Now, S minus 3 can cancel this one. We are left with S minus 2, S minus 1, which will multiply A. So we have A multiplying S minus 2, S negative 1. Alright, plus B. Now, B, what do we have here? S minus 2. It will cancel this one. We are left with S minus 3, S minus 1. So that is what will multiply B. So we have S minus 3 times S negative 1. Then we go to C plus C. Now C, we have the denominator to be S minus 1, which will cancel this one. We are left with this and this. So C times S minus 3, then S minus 2. Now listen, compare the denominators. This and this are the same, so we don't need it. We equate the numerators. So equating the numerators, we have everything here must be equal to everything here. So, okay, so now whatever that we have in the brackets are very simple for us to solve. We can use cover up method to solve this. Okay. Now, cover up method means if I make S to be 2 here, I can make A to be 0 and I can find B. Don't forget, if S is 2 here, C2 will be what? 0. So we can pick any of these brackets and equate it to 0. So let's start with A. Okay, let's start with S minus 2. So when S minus 2 equal to 0, then we have S is equal to 2. So wherever that we have S, we substitute what? 2 into this equation, and let's see the result. So when we do that, once I put 2 here, the whole function here becomes 0. Then when I put 2 here, the whole function here becomes 0, and we are left with b, so we can find the value of b. Don't forget, you substitute s to this side too, the left hand side of the equation. So we have 5 into 2 all square minus 23 into 2 plus 28 equal to, we know all this side will be 0, all this side will be 0. So equal to b into 2 minus 3 multiplying 2 minus 1. So 2 square will give us 4. 4 times 5, we are having 20 here. This time this, we are having minus 46 plus 28 equal to, now when you subtract this, the result is what? B into negative 1 when you subtract this into 1. So this result, when we add 20 plus this is 48. 48 plus this, we have 2 equal to what? Minus b. Alright, so we are looking for b, the value of b. So you divide through by negative 1. So therefore, b is equal to negative 2. Now, from the same cover-up method, when we make s minus 3 to be equal to 0, we can find the value of what? A. So when we pick s minus 3 to be equal to 0, we can find the value of what? A. Because when we substitute 3 here, this whole side will be 0, this whole side will be 0. So in the next step, you just write that when s minus 3 equal to 0, then we have s equal to what? 3. So when s is equal to 3, let's substitute that into the original equation. This is giving us 5 into 3 all squares, starting from the left hand side, looking at this one. So minus 23s plus 28, giving us this side, which is a into 3 minus 2, 3 minus 1. Okay, don't forget, I don't need to write this step because when I put 3 here, everything here is what? 0. So now we work on this one. There's a mistake here. I'm putting 3 here. So this is 3. Alright, so from here, this is giving us 9. 9 times 5, we are having 45. This is minus 69. So 69 plus 28, giving us what? When you subtract this, we have 1. When you subtract this, we have 2. 2, 1 will give us 2. 2 times a will give us 2a. So when we add this result, 45 minus 69 plus 28, we are having 4. Yes, so 4 equal to what? 2a. So now we can find a by dividing through. So therefore, a equal to what? 4 divided by 2a equal to 2. Okay, so now let's find the value of c. Now watch very carefully. Using the same cover-up method, we can find c. Now we can work with s minus 1. If we pick s equal to 1, this side will be 0, a will move to 0, b will move to 0, then we can find c. Because when we substitute 1 here, we will not get 0 on this side. Alright, so when s minus 1 equal to 0, s is equal to 1. So we have 5 into 1 all square minus 23 into 1 plus 28. So this is equal to c into 1 minus 3, then another 1 minus what? 2. So when we work on this, what are we having? This and this will give us 5 minus 23 plus 28, we have 10. Okay, so 10 equal to what? Negative 2 times negative 1 will give us what? 2. Alright, so 2c. So 2c. So therefore we can find c by saying that c equal to 10 over 2, which is 5. So okay, so with this result, we can put in the values of a, b, and c. Okay, so this is equal to 2 over s minus 3. Then b was negative 2, so plus, let me put it in brackets, minus 2 over s minus 2 plus 5 over s minus 1. Okay, remember that this side was the same as x bar coming from here, so I can replace everything I have here with x bar. So now when we get here, we need to find the Laplace inverse of this result to complete the calculation, and I think we are almost done. So let's take the Laplace inverse of this. This is giving us the Laplace inverse of x bar will give us Laplace inverse of its result. So we have 2 over s minus 3 plus minus 2 over s minus 2 plus 5 over s minus 1. So this is it. Now to make the work very simple for you, I'll factorize all these values out and rewrite it as Laplace inverse of 2 times 1 over s minus 3. This can multiply to get that, minus 2 times 1 over s minus 2 plus 5 times 1 over s minus 1. Okay, so this makes it very simple for me to take the Laplace inverse. Alright, so let me take you back to the inverse. You can locate inverse transform in the same playlist, Introduction to Laplace Transform Part 3, to equip yourself with inverse transform. Okay, so here I'm not going into details. In the beginning, I told you that the Laplace transform of the function e to the power at is giving us 1 over s minus a. And when we substitute a value for a, then we have e, let's say 2t is giving us 1 over what? S minus what? 2. The Laplace transform of this result is this. So the reverse of this is the inverse. Okay, so when I take the inverse of this one, I'm supposed to generate what? E to the power of 2t. Do we get it? Alright, so if I have e to the power negative at, then the Laplace transform of this will give me the result 1 over s plus what? A. If this is negative, this is positive. Okay, so when I put a value here, let's say negative 3, then this result becomes what? Plus 3. Alright, so we apply this. So the inverse of this one will generate what? E to the power minus 3t. Alright, so that is why I decided to factorize these values out to make it very simple for us. So now when you take the inverse of x bar, the result is what? X. Remember that the Laplace transform of x is x bar, so its inverse is what? X. And this is equal to 2 times. Now, what is the Laplace inverse of this? Don't forget this is what? The value a. So this is the same as e to the power what? 3t. I told you if this side is positive, this becomes negative. Alright, then we have minus 2 times the same thing, e to the power 2t plus 5 times e to the power what? This is 1, so it's supposed to be what? 1t, which is the same as t. So the Laplace inverse of this result is the same as x equal to 2e 3t minus 2e 2t plus 5e to the power t. And this is our final result. So x equal to this function that we have. My name is Daniel. This is Youth I Think. Please support this work by subscribing to this channel. See you in the next one.